5.2 deals with inequalities in a triangle. Make sure you fill out your table of contents. We're going to call this 5.2 Inequalities and Triangles. So get ready for some notes. First, a theorem. This theorem is called the exterior angle inequality theorem. So if you recall, we have the exterior angle theorem, not the inequality theorem, but just the plain old exterior angle theorem. And that says if we have a triangle and an exterior angle, then angle 4 is equal to the sum of the measures of angles 1 and 2, right? The two remote interior angles. Well, the exterior angle inequality suggests, therefore, angle 4 has a greater measure than the measure of angle 1, and likewise, measure of angle 4 is greater than the measure of angle 2. That's basically it, right? If the measure of angle 4 equals 1 plus 2, that means 4 is greater than 1 and 4 is greater than 2. So in terms of specific wordage, I think your textbook has something like, in a triangle, if an angle is an exterior angle, then its measure is greater than the measure of either two of its remote interior angles. Or in abbreviation form, in one triangle, if you have exterior angles, then it is greater than either remote interior angle. So here's an example. This is kind of a crazy example. You might want to sketch this in your notes. So first example using this diagram, list all angles with measures that are less than the measure of angle 14. So we see 14 is up top. It's kind of an exterior angle to many triangles. And I'll walk you through which angles are indeed less than 14. So take a look first at this upper triangle, that one. We see that 14 is an exterior angle, and 4 and 11 would be considered its remote interiors. So that means angles 4 and 11 have measures less than angle 14. Now let's take a look at, wait a minute, 11 and 9 are vertical angles. So therefore, angle 9 is also less than angle 14. Now let's consider this triangle. Angle 14 is still an exterior angle. And so therefore, angle 4 is already listed, but angle 2 must be less than 14, and angle 3 must also be less than 14. 3, because 3 and 4 together were less than angle 14. So therefore, angle 3 on its own must be less than 14. Now this next part is where it gets kind of strange. Take a look at angle 11. Angle 11 is an exterior angle in this triangle. And as a result, angle 11 is greater than its remote interior angles, 6 and 7. And so if 14 is greater than 11, 11 is greater than 6 or 7, that means 14 is going to be greater than angles 6 and 11 as well. Let's look at another example using this exact same diagram, but now the problem asks, list all angles with measures greater than angle 5. So we have to ask ourselves, for which triangles is 5 a remote interior angle? So here's one possibility. We see we've got this triangle, and 17 is an exterior angle to 5 as its remote interior. Here's another possibility, and so therefore 10 must be greater than 5. Likewise, 12 is going to be greater than angle 5. Now consider 15 must be greater than 12. 12 is greater than 5, and if 15 is greater than 12, therefore 15 must be greater than angle 5 as well. Likewise, we had that one other one, angle 10. Well, angle 10 also has an exterior angle. And so if we look at 16, 16 is bigger than 10, and 10 is bigger than 5, so therefore 16 is going to be greater than angle 5 as well. And just kind of little puzzles. So another theorem, this is kind of based on kind of an obvious fact, but if you consider the largest side, BC in this triangle, the longest side is opposite the largest angle. Now the same holds true for the shortest side. We see the shortest side is opposite from the smallest angle. And so this is actually a theorem. So this theorem, we say in one triangle, if the measures of two sides of a triangle are unequal, then the angles opposite those sides are unequal in the same order. In other words, BC is opposite angle A, therefore BC would be the largest side, so angle A would be the largest angle. So in abbreviated form, in one triangle, if two sides are unequal, then angles opposite them are unequal in the same order. So we can turn this around. Right now this says if the two sides are unequal. Well, the same holds true in the opposite direction. The largest angle is opposite from the longest side, and vice versa. The smallest angle is opposite the shortest side. And so we have this third theorem that says essentially the converse. If two angles are unequal, then the sides opposite those angles are unequal in the same order.